Electromagnetic radiation is the radiant energy released by certain electromagnetic processes. Visible light is one type of electromagnetic radiation. Other familiar forms are invisible electromagnetic radiations, such as radio waves, infrared light and X-rays. Classically, electromagnetic radiation consists of electromagnetic waves, which are synchronized oscillations of electric and magnetic fields that propagate at the speed of light through a vacuum. The oscillations of the two fields are perpendicular to each other and perpendicular to the direction of energy and wave propagation, forming a transverse wave. Electromagnetic waves can be characterized by either the frequency or wavelength of their oscillations to form the electromagnetic spectrum, which includes, in order of increasing frequency and decreasing wavelength, radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays and gamma rays. Electromagnetic waves are produced whenever charged particles are accelerated, and these waves can subsequently interact with any charged particles. M-waves carry energy, momentum and angular momentum away from their source particle and can impart those quantities to matter with which they interact. Quanta of M-waves are called photons, which are massless, but they are still affected by gravity. Electromagnetic radiation is associated with those M-waves that are free to propagate themselves without the continuing influence of the moving charges that produced them, because they have achieved sufficient distance from those charges. Thus, EMR is sometimes referred to as the far field. In this language, the near field refers to M fields near the charges and current that directly produced them. Specifically, electromagnetic induction and electrostatic induction phenomena. In the quantum theory of electromagnetism, EMR consists of photons, the elementary particles responsible for all electromagnetic interactions. Quantum effects provide additional sources of EMR, such as the transition of electrons to lower energy levels in an atom and blackbody radiation. The energy of an individual photon is quantized and is greater for photons of higher frequency. A single gamma-ray photon, for example, might carry 100,000 times the energy of a single photon of visible light. The effects of EMR upon biological systems depend both upon the radiation's power and its frequency. For EMR of visible frequencies or lower, the damage done to cells and other materials is determined mainly by power and caused primarily by heating effects from the combined energy transfer of many photons. By contrast, for ultraviolet and higher frequencies, chemical materials and living cells can be further damaged beyond that done by simple heating, since individual photons of such high frequency have enough energy to cause direct molecular damage.